Welcome to the Connect with BMC Helix ITSM webinar series. During today's webinar, you're able to ask questions of our panelists. The questions and answers, along with today's presentation, will be published to our channel a week from today's broadcast. Today's topic is Discovery Administration Best Practices, and Philippe Boyer will take us through this content. Over to you, Philippe.
Thanks, Greg. I am Philippe Boyer, support engineer. I have been working in BMC customer support for 10 years now. I am specialized in discovery issues and Helix discovery issues. This presentation is not about Helix discovery. If you are using Helix discovery, you do not have to worry about the administration because BMC will do it for you. Here is the agenda. In the overview, let's briefly review what is discovery and what are the most impacting issues. We will check how to avoid them with administration best practices. And we will review some common issues in the troubleshooting part. Very quickly, discovery discovers your assets and the dependencies between them. The most impacting discovery issues are downtime and data loss in general. In practice, this is disk full, performance issues, data store corruption, and core dumps. This presentation will tell you how to minimize the probability of this issue. This impact diagram is available in our knowledge base. You will find it in the references of this webinar. It shows the most impacting issues and the relations between them. The goal of this diagram is to show that these issues are interconnected. For example, a performance issue can cause a disk full issue. A disk full can cause a data store corruption, and a data store corruption can cause another disk full issue later. I am going to show you what is the best way to prevent these issues from happening. If you want to be successful in your discovery administration and maintenance, if you want to prevent the most impacting issues from happening, if you want to mitigate their impact and resolve them faster with less effort, the three most pertinent things to do is to monitor, backup, and compact. The most pertinent things to monitor are the free disk space and the DDD removal statistics. DDD is a particular type of node. Discovery deletes this node in a low priority background process. When this is not done correctly, this means that an issue is going to happen soon or later. If you monitor the free disk space, it will allow you to diagnose that something is not working correctly, and it will allow you to take actions before disk full issues or performance issues happen. If you monitor the free disk space, it will allow you to diagnose that something is not working correctly, and it will allow you to take actions before disk full issues or performance issues happen. Now, I am going to show you how to monitor the DDD removal statistics. To do that, let's go to the Discovery GUI. I'm going to remind you where to go to see the DDD removal statistics. You have to click on Administration, and then scroll down, and then click on Performance. In the Performance page, you have the DDD Removal tab. Click on it. So this is the place where you can monitor DDD removal statistics. In this appliance, there's no particular information, but I'm going to show you other examples. This page shows you real example of DDD removal statistics. At the top of the screen, you have the DAs in the data store. This is a type of DDD node. A discovery access is created almost each time an IP address is scanned. And the volume gives a good indication of how big is the volume of data in your data store. The most important thing are the orange and red waves. The red wave is the number of DAs eligible for removal. It means that they are not yet removed, they are just eligible. In this particular example, as you see, the number of DAs eligible for removal keeps increasing forever. And that's the same for the DAs in the data store. So it indicates a problem. The last wave is the orange one. That's the DAs pending for removal. It is waiting for a particular process to actually get rid of them. In this example, something goes wrong, and that's the moment to take actions, because if things continues like that, this is probably going to cause a disk saturation and then a downtime and maybe a data loss. In this example, you see other phenomenon, like for example, the red wave, that is the DAs eligible for removal, that was stuck at a very high level, and suddenly it starts decreasing. And then logically, the number of DAs pending for removal increases at the same time. This is what you see at this particular place in 2019 in October. That's normal. When Discovery starts deleting things, the number of things eligible for removal decrease and the DAs pending removal increase. So that's what I wanted to show you regarding the DDD removal statistics, and that's the end of the demo. Let's review now the next best practice, backup. You can name this backup plan high availability, disaster recovery, or business continuity plan. What we recommend is to always be able to restore Discovery. We wrote one knowledge base article that gives options to implement this backup plan. The reference of this article is at the end of this slide, and you will find it in the references of this webinar. I remind that a backup plan is recommended even in the case of a cluster with fault tolerance enabled. The backup itself won't keep issues from happening, but it will allow you to resolve issues faster, mitigate their impact, avoid losing time, data, and money. I remind that once you have a designed backup plan, it is recommended to test it and to automate it. Let's review some examples of backup plans. In the first example, we are going to review the case of a consolidator that synchronizes a CMDB. In this case, the appliance does not scan anything. It just consolidates the data from scanners. One of the options is to export the root node keys time to time. Root node keys exports gives a way to reinstall a consolidator, let the scanner rescan the same data, update the consolidator, and resynchronize the CMDB without causing other issues. In the second example, let's imagine that you have 3 scanners, 1 consolidator, and a CMDB. One of the options is to shut down everything and take a VMware snapshot of everything, including the CMDB. In case of problem, it would allow you to restore everything. I insist it is important to stop everything before taking a VMware snapshot, otherwise the restore will corrupt the data. In the third example, let's imagine that you have a pair of appliances to do the same thing. Using a pair of Discovery appliances would allow you to immediately start using the second one if the first has a problem. Once the backup plan is designed and tested, it is recommended to automate it. We have written a knowledge base article to automate your backup plan. You will find it in the knowledge base article mentioned in this slide. It will be part of the references of this webinar. Administration best practices, compact. What is fragmentation? This is about the way the data is structured in the data store files. This structure changes over time, so the files take up an unnecessarily large amount of disk space And beyond a certain point, this can cause performance and health issue. What is compaction? This is a simple maintenance operation that removes the fragmentation. It reduces the data store size, the storage usage, and increases the performance. To compact the data store, you only have to stop the discovery services and run one command, tw offline compact. You can find it in the documentation. We did our best to document that it has to be done, but by experience, it is frequently omitted or delayed. We recommend to automate the compaction. To do that, you can use cron to execute a custom script that stops the services and compact the data store. We have written a knowledge base article to do that. You will find it at the bottom of this slide. We remind you that we have a list of troubleshooting guides. You can find them in docs.bmc.com. This slide shows the first page of discovery documentation, and the troubleshooting section is at the bottom. It currently contains troubleshooting guides about common issues like cluster issues, disk space issues, or scan issues. We often update them, and we encourage you to read them. Let's review a common issue and how to troubleshoot it. The scans are slower than expected. There are multiple possible root causes, but the most frequent one are that the compaction is not frequent enough or it has simply never been executed. When the compaction is not executed, the data store grows. When the data store grows, the data store takes more memory. And of course, beyond a certain point, it's going to swap. It's going to slow down everything, and it's going to start accumulating nodes in the data store, which is going to aggravate the problem. So that's the reason why the compaction is very important to execute. The second most common root cause is that the monitoring of the DDD removal is not frequent enough. The DDD removal monitoring would allow you to detect, for example, that you are accumulating too many nodes, too many DAs, or it could also allow you to detect that something keeps discovery from deleting things or deleting them fast enough. When this is not done, of course, the data store is going to accumulate more and more nodes. The size is going to increase, and then, a bit like the problem caused by the lack of compaction, it is going to create a performance issue that is going to aggravate the disk consumption, that is going to aggravate the performance issue, and so on. So that's the reason why the lack of monitoring of the DDD removal is a frequent root cause for performance issue. The other common root cause is that the scan activity is simply bigger than what the hardware can handle. Sometimes you need more hardware than documented in the minimum requirements to scan what you want to scan. Sometimes it's because you have a lot of customization, custom patterns. Sometimes it's also because you have generated patterns with CAM, or you're using a lot of complex SAM models. So sometimes you have to add more hardware to do what you want to do. And as soon as the hardware is not big enough to do what you want to do quickly enough, then Discovery is going to start accumulating things on the disk, files on the file system, nodes in the data store, and all this is going to slow down Discovery and then aggravate the disk consumption issue. And then at the end, the scans are going to be slower and slower. The solution for these most common causes are very simple. The most pertinent thing to do is, once again, to monitor and compact. Monitor the disk consumption because it's going to allow you to anticipate future performance issues, and compact because it's going to give Discovery a chance to simply go faster. We have a knowledge base article that reminds all the possible root cause and different recommendations to resolve them. So let's check now another common problem. This is when the disk is full, and then you have this message in the GUI saying that the appliance has shut down because the available disk space is low. The most frequent root causes, of course, once again, there's a lot of things that can cause this issue, but the most frequent ones are, first of all, the performance issue. That's the issue that we've just reviewed in the previous slide. Because again, when there is a performance issue, it's going to lead the disk to grow, the disk consumption to grow. And at the end, you could end up with this problem. The second most frequent root cause is a data store corruption because it caused core dumps. And core dumps very frequently fill up the disk. It's interesting to note that when there is a disk full, there is a risk of data corruption. In other words, a disk full can cause another kind of disk full. That's the reason why many aspects of the health, the performance, the disk consumption are linked together, like in the impact diagram that I shown you at the beginning of the presentation. The other most frequent root cause is that sometimes there is one of the member cluster that is down. It could be, for example, because of a data store corruption that caused a core dump and that stopped a particular member. The problem is that if the other members keep scanning and nothing is done to remove the member that is down, then the data store is going to grow. This is because when a member is down, the deletion activity is stopped. And then Discovery is going to accumulate everything and it's going to stop deleting anything. The result is that if you let the scan run without checking time to time the health of your cluster to make sure that everything is up and running and to take action if a member is down, then you could easily end up with a disk full issue. Again, the most pertinent things to do to keep this from happening is to monitor, backup, and compact. We also have a knowledge base article that does not only talk about the ways to prevent this issue from happening, but it contains the list of possible causes and the solution for the issue. We're going to review another common problem. The next common problem are core dumps. The most frequent cause for core dump, of course, there are many different causes, but the most frequent one are the performance issue, the disk full, because it causes a data corruption sometimes, and also the unsupported procedure that can lead to a data store corruption. Regarding performance issue, we talked about the link between core dumps and performance issue. A performance issue can lead to a disk full, and a disk full can lead to a data store corruption, and a data store corruption can lead to a core dump. So that's one of the possible chain of root causes between a performance issue and a core dump. We also observe that there is frequently a link between the load and the core dump, the load and the data store corruption. Regarding the unsupported procedure, there are many user error that can be done, and in particular, as soon as you execute a procedure that is not documented. What we typically see in support is the case where someone confused, for example, the logs and the data store logs. And sometimes, because of this confusion, some customers delete the data store logs instead of the logs of Discovery. And of course, when this kind of thing happens, that's an unsupported procedure, and it is going to corrupt the data immediately. There will be no way to repair that. Another type of frequent unsupported procedure, that's about the restore procedure and the backup. It's important when you use VMware snapshots to stop all the members at the same time before taking the backup. If you let them run and you take a VMware snapshot, the problem is that there will be a desynchronization between the status of each members. And when you will restore such backups, such VMware snapshots, then it's going to lead to corruption because the data stores of the different appliances of the different members will not be at the same page. They will be desynchronized. And then this is going to lead to a data store corruption, and the data store corruption can lead later to core dump. The best to prevent this kind of core dumps from happening is, again, to monitor backup and compact. Of course, we can add to this to make sure that you only execute supported procedures, procedures that you will find in the documentation and nothing else. We can also recommend to execute them carefully to make sure that there's no user error. We have a knowledge base article that is mentioned at the end of this slide that explains all the way to diagnose the root cause of a core dump and repair the data store corruption when that's the cause. This is the end of this presentation. This is the list of references. You can retrieve them at the end of this webinar. I remind that we have reviewed the 3 most important best practice: monitor, backup, and compact. We have reviewed the most impacting issues that should be avoided or mitigated thanks to this best practice. That is the disk full, performance issues, core dumps, and data corruption. This concludes my presentation. Back to you, Craig.
Thank you. And now I'll take us through the self-help in contacting BMC. The YouTube channel where this webinar will be posted is listed here. It contains past webinars as well as a rich set of how-to videos. The Connect with BMC Helix ITSM and Remedy webinar schedule is available at this community's link, and the hot off the press newsletter for trending information is available at this community's post. As always, contacting technical support via web, phone, email, and these social channels is available. At this time, that will conclude this webinar. Thank you for attending.